Have you ever just looked at the sheer amount of data your business generates? I mean, sales figures, customer reviews, logs, maybe even like images from inventory,
Yeah.
and felt just a bit swamped.
Oh, definitely. It's like you're sitting on this potential gold mine. Yeah.
Exactly. But turning it into actual insights,
Yeah.
something that can really predict what's next or spot hidden issues, it just feels like this massive, massive climb.
Yeah, the how is the tricky part.
Right. Maybe you're dreaming about predicting next quarter's sales perfectly, or, I don't know, instantly flagging some weird transaction that just screams fraud.
Or even like automatically writing personalized marketing copy for every single customer. That's the dream.
Totally. But then reality hits you learning new code, the absolute nightmare of shifting huge data sets around, or just what even is AI, really?
That can feel really inaccessible.
What if you could just flip that whole script?
Mhm.
What if you could turn your raw data into this powerhouse of intelligent insights, predicting, spotting anomalies, even generating new stuff, all without becoming a coding genius or doing those crazy data migrations? That sounds pretty good.
Okay, so let's actually unpack this. Imagine, just for a second, this one platform where all your data already lives, your big data warehouse. And suddenly, it just gains the ability to talk directly to these super powerful AI models.
Okay, interesting.
Today, we're doing a deep dive into BigQuery ML. And this isn't just like another tool update. It's genuinely becoming an AI powerhouse, bringing really cutting-edge AI, including all that generative AI magic, right to where your data sits.
Right.
And the key is, you can often do it using the SQL you might already know and love. It's all about empowering you to do these incredible things with your data, but without all the usual headaches.
What's really fascinating here, I think, is how BigQuery ML is specifically engineered to make this advanced AI stuff accessible, to way more people.
Right.
Our sources really detail its seamless, almost like magical integration with a whole bunch of Google Cloud AI services, and it can handle pretty much anything: unstructured text, audio, even complex images and video.
So our mission for this deep dive is really to show you not just how this integration works, but to really reveal the incredibly wide range of AI tasks you can actually perform.
Okay.
We'll cover everything from the cutting-edge generative AI, the stuff that creates and understands content, all the way to the really powerful, established traditional machine learning techniques.
The workhorses.
Exactly, the workhorses, and crucially, it's all achievable directly within BigQuery. So we'll explore the what, the how, and maybe most importantly, the why this actually matters for your own data projects, and how it just dramatically simplifies that path to using AI's potential.
Thinking back, traditionally, if you wanted to apply some serious AI to those huge data sets,
Yeah.
it felt like conducting an orchestra, didn't it?
Yeah, a very complex one.
You'd have to pull the data out from wherever it was living, then you'd have to massage it, transform it into just the right format for whatever specialized AI service you were using.
Right, the ETL nightmare.
Totally. Then you'd ship it off to maybe some specialized platform or maybe a custom model you'd painstakingly built yourself.
Uh-huh.
And then, after the AI did its thing, you had the equally tough job of figuring out, okay, how do I get these results back? How do I blend them with my original data and actually make them useful?
Yeah, it was often incredibly complex, painfully slow.
And frankly, it raised huge security questions, right?
Yeah.
There's sensitive data just hopping between different systems. It was a logistical headache that probably stopped a lot of good ideas dead in their tracks.
That whole scenario you just laid out, that's precisely where BigQuery ML just completely shifts the paradigm.
Okay.
The fundamental idea is brilliantly simple, really, but it's incredibly impactful.
Okay.
You keep your data securely in BigQuery, right where it is.
Right, no moving.
Exactly. BigQuery ML then brings the powerful AI capabilities to your data rather than you having to push your massive, valuable data to the AI.
Okay, that makes sense.
And this approach, while it saves enormous amounts of time, just think, no more complex ETL processes just to prep data for AI.
Yeah.
It drastically cuts down complexity because you've got your data storage and your AI happening in one place. And critically, it significantly boosts data security, your massive data sets. They stay put in the controlled, secure environment of BigQuery.
That's huge.
It is. And it means you can leverage sophisticated AI using often just the SQL queries you already know. It kind of abstracts away all that underlying complexity of the AI services.
So your data folks can focus on getting value, not just wrangling data pipelines.
Exactly. Focus on the insights, not the plumbing.
Okay, here's where, for me, it gets really interesting, like truly game-changing level. How does BigQuery ML actually connect to all these advanced AI capabilities, the language models, the vision APIs,
Yeah.
without moving data, without you writing complex Python, without managing API calls directly.
Right. How does the magic happen?
Yeah. It uses this ingenious thing called a remote model. Now, don't get thrown by the name.
Mm.
A remote model isn't actually storing the AI model itself.
Oh, okay.
Think of it more like a special secure shortcut or like a direct connection inside BigQuery.
A pointer, almost.
Exactly, a pointer. It just points to existing pre-trained AI models. These are often hosted and managed over on Google Cloud's Vertex AI. That's their big AI platform, or maybe other specialized cloud AI services.
Got it.
It's basically like having a secure internal teleporter. It sends your specific data snippet over to the AI model for processing, gets a result, and beams it right back into your BigQuery table. But your main data set, it never really leaves the secure BigQuery zone.
That's a really elegant solution, actually.
Isn't it? It solves a really complex problem very neatly.
So, okay, this brings up a key question.
Yeah.
What are the real, tangible advantages for you, the person working with the data, using this remote model approach?
Yeah, what's in it for me?
Well, first and foremost, there's incredible simplicity. Like you said, no need to write complex Python, wrestle with API keys, manage those direct API calls. It's all handled through familiar SQL. That simplifies your workflow like crazy.
Okay, simplicity check.
Secondly, and this is absolutely critical today, data security. We just talked about it. Your massive data sets stay securely in BigQuery, period.
Peace of mind.
Huge peace of mind. It cuts out the risks and the overhead of moving sensitive data around, less compliance headache too.
Point.
Thirdly, and this is a massive leap for a lot of organizations, you get to leverage pre-trained state-of-the-art AI. You're not building, training, or managing these complex models yourself.
Right, you're tapping into Google's brainiacs.
Pretty much. You're tapping directly into Google's AI expertise, their advanced research. These models are trained on massive data sets, constantly refined. You get cutting-edge performance with minimal effort on your end.
Like getting the power of Google search for your own data analysis.
Kinda, yeah. Accessing that level of capability with just SQL. And that brings us to the final point. SQL accessibility. This is the real democratizer.
Yeah.
You can perform incredibly complex AI tasks, stuff that used to need specialized programmers, a whole data science team, just using the SQL you probably already know. It opens up AI to so many more people, analysts, engineers, even some business users who understand their data but aren't deep learning experts.
That really lowers the barrier to entry, doesn't it?
Absolutely.
Okay, so when we talk about generative AI or Gen AI, yeah, most people's minds jump straight to like ChatGPT writing an essay or Midjourney creating amazing pictures or maybe even Copilot writing code.
Right, the creation aspect.
Absolutely. And while that's definitely a core part, in BigQuery ML, generative AI goes even further. It uses these powerful large language models, LLMs, like Google's Gemini, to not just create new stuff, but also to deeply analyze, understand, and pull out really profound insights from both text and visual information you already have in your data.
Ah, so it's understanding and creation.
Exactly. It's about comprehension and transformation of your raw, unstructured data, not just generation.
That leads us perfectly to probably the most versatile, most powerful function for Gen AI inside BigQuery ML Generate Text.
Okay.
The workflow is actually pretty straightforward. First, you create one of those remote models we talked about, specifically pointing it to a Gemini model, one of Google's top LLMs.
Right. Establish the connection.
Once that secure link is set up, you can use ML Generate Text with your data and a prompt. And the prompt is basically just your instructions in plain English. You tell the model what you want it to do with your data. It's surprisingly intuitive.
Okay, so you just tell it what to do?
Pretty much. And let's really dig into some of the most impactful ways you can use this, some practical examples that could genuinely revolutionize how you work with data.
All right, let's hear them.
Okay, first up, content generation. Imagine you're in marketing, right? You've got product features sitting in a BigQuery table. Instead of manually brainstorming slogans for hours, you could prompt Gemini to whip up several creative options for each product, just like that. Or think about personalizing customer communication. You could tailor product suggestions for individuals based on their purchase history, their preferences, all stored right there in BigQuery, generate super tailored recommendations, maybe even draft the email copy, all within SQL.
Turning your data into a creative partner.
Exactly. It becomes a creative engine. Then there's text analysis and classification. Think about the sheer volume of, say, customer feedback, survey answers, social media comments.
Mountains of text.
Right. Instead of someone manually reading thousands of them, ML Generate text can automatically slap labels on them, like sorting customer reviews into product feedback, support request, billing question, feature idea.
So you get an instant overview.
Instantly organized. You see the themes, you can prioritize, respond way faster.
Nice.
Closely related is sentiment analysis. This lets you quickly figure out the emotional tone of text. Is feedback on a new feature overwhelmingly positive? Kind of neutral? Definitely negative.
Get a quick pulse check.
Exactly. Rapid insight into how people feel, letting you react quickly to market shifts or maybe product issues.
Okay, makes sense.
Now, for anyone dealing with loads of documents, content summarization. This is a huge one. Imagine condensing massive legal reports, long research papers, detailed meeting notes into short, easy-to-digest summaries.
Oh yeah, that would save hours.
ML Generate Text can do that. Save your team tons of reading time. Let them grasp the key points of huge text without getting bogged down.
That's incredibly valuable.
Definitely. We can also talk about entity identification. This is about automatically finding key things mentioned in text, people, places, companies, product names, technical terms.
Pulling out the important nouns.
Pretty much. Like, quickly extract all the company names mentioned across a news archive. And this isn't just for text. It can find entities and images, too, adding searchable context to your visuals.
Ah, interesting.
And translation and transcription super powerful for global businesses. Convert text between languages, perfect for understanding international customer feedback or localizing your own content.
Break down those language barriers.
Exactly. And similarly, turn spoken audio voicemails, customer service calls, meeting recordings into searchable text. Imagine automatically transcribing all your service calls. Suddenly, that huge pile of audio data is analyzable for trends, agent training, compliance.
Turning audio into actionable data. Powerful.
And here's where it gets really innovative. Visual understanding with multimodal data. ML Generate Text isn't just for text. It cleverly handles images and video, too.
Multimodal, meaning multiple types of data.
Exactly. You can use it for visual captioning, automatically describing what's in a picture. Like, it sees a photo and generates a dog playing fetch in a park. Now you can search your images using natural language.
Search pictures by describing them. Cool.
Yeah. Or even visual Q&A. Ask the model questions about an image. Get text answers back. What color is the car in this picture? It really bridges that gap between visual and textual data, unlocking totally new ways to search and analyze your visual assets.
Okay, that's impressive. But what's really grabbing me about using these Gemini models in BigQuery ML is, well, you mentioned it's not just basic text generation. You get these advanced controls.
Oh, yeah, absolutely. You can really fine-tune how the model behaves.
Like what? Tell me about grounding. That sounds important.
It is really important. Grounding lets you explicitly tell the Gemini model to use specific factual information from trusted sources. Maybe the open internet, but crucially, maybe your own internal knowledge base, your company document,
How would you do that?
to make its responses much more precise and accurate. Think about it. If an LLM hallucinates, just make something up when summarizing, say, clinical trial data for a pharma company.
Oh, wow. Yeah. Disaster.
Exactly. Grounding reduces those hallucinations by forcing the model to stick to verified facts from the sources you provide. It turns this probabilistic AI into something you can actually trust for really critical tasks. It's a bridge to reliability.
Okay, so grounding equals more trustworthy AI.
Yep.
Got it. What about safety attributes?
That's about setting rules and filters. You ensure the generated responses stick to your content guidelines, automatically filtering out harmful, inappropriate, or just undesirable stuff. Absolutely vital for brand safety responsible AI use, especially if it's customer-facing.
Right. Keeping it clean and appropriate.
Yeah.
Makes sense. And you mentioned supervised tuning for some models.
Yes. For certain advanced Gemini models, when you're creating that remote model connection, you can actually fine-tune the base model using your own specific data sets.
So teaching it my company's specific stuff.
Exactly. It's like taking a brilliant generalist and making them an expert in your specific niche. If you have examples of, say, perfectly summarized legal docs from your company, you feed those in during tuning. The model becomes much better tailored to your tasks, your data patterns, your specific language.
So it gets even better at my specific job.
Significantly better. And one more for places with really high demand, there's Vertex AI Provision Throughput. Basically, you can reserve dedicated processing power just for your Gemini models. This guarantees consistent, high-volume performance, essential if you're running mission-critical applications where speed and reliability are non-negotiable.
So you can scale it up for heavy use.
Precisely. These advanced options really take generative AI in BigQuery ML beyond basic use cases, allowing for highly customized, reliable, enterprise-grade deployments. Now, shift gears slightly. Imagine you're sitting on just a massive pile of unstructured text, thousands of customer reviews, maybe hundreds of thousands of support tickets, millions of product descriptions.
Okay, a text mountain again.
Right. Instead of just summarizing, what if you could automatically pull out specific structured data from each piece of text and populate a perfectly clean, database-ready table?
Whoa, like automatically fill a spreadsheet from free text.
Exactly. That's what the AI generatable function does. It's currently in preview, but incredibly powerful. You tell the Gemini model, read each review and give me back a table with these columns. Customer, product name, sentiment, key features mentioned. You just define the SQL schema you want.
And it just does it.
And the AI does the heavy lifting. It extracts and formats the info. It's like having this tireless, intelligent data extractor automatically creating structured insights from messy text. No custom parsing code needed.
That is seriously cool, transforming text into database rows automatically.
It's a huge time saver and unlocks so much data.
Okay, so what if you need something even more specific, like pulling out just one single value from each row's text, maybe a number, or a simple yes, no, or just one specific phrase?
Right. For that really granular extraction, BigQuery ML has a suite of scalar functions.
No.
AI generate bool, AI generated double, and AI generate.
Scalar meaning single value.
Exactly. They're designed to analyze the text or content in each row and return just one specific type of value. For instance, say you have product descriptions and want to flag the eco-friendly ones.
Yeah.
You could use AI generate bool with a prompt like, does this description imply eco-friendliness? It would just return true or false for each product row.
Simple yes, no flag.
Or maybe you need to pull out a numerical rating embedded in review text or a quantity mentioned in a report. AI generated double can grab that number for you.
So it's about extracting very precise little nuggets of information programmatically.
Precisely, directly within your SQL query. It's like having a tiny, smart assistant looking at each row and pulling out exactly what you need.
That's neat. Very targeted.
Okay, so if generative AI is about creating stuff, then embeddings. Embeddings are really about helping AI understand similarity, context, relationships within your data.
Understand, not create.
Right. And the function for this is ML generate embedding. What it does, essentially, is convert data, could be text, images, even audio, into these high-dimensional numerical vectors. Think of them as numerical fingerprints.
Okay, numbers representing meaning.
Exactly. That's the brilliance. Things that are semantically similar, they mean similar things or have similar characteristics, end up with embeddings or fingerprints that are numerically close to each other in this high-dimensional space.
So similar ideas get similar numbers.
In a nutshell, yes. Similar concepts cluster together numerically.
Okay, so you turn stuff into numbers. Why is that useful?
Oh, it unlocks some incredibly powerful applications. One of the biggest game changers right now, especially for LLMs, is retrieval augmented generation, or AG.
RAGSHI.
Yeah.
Heard that acronym.
You probably have. Imagine you want your LLM to be more factual, less prone to making stuff up, right?
Yeah.
RReg lets the LLM look up relevant information from your own private trusted data like internal company docs, product manuals, FAQs. It uses embeddings to find the pieces of your data that are most semantically relevant to the user's question.
So it searches my stuff first.
Yes, it grounds the LLM's response in your specific, accurate knowledge base. This massively improves accuracy and trustworthiness, crucial for things like internal knowledge bots or customer service AI.
Solving the hallucination problem by using my own facts. Smart.
Very smart. Embeddings also power multimodal search. This breaks down those data silos we hate. You can search across different types of data.
Wow.
You can use a text query like happy customers and find not just text documents, but also relevant images of smiling people, or even video clips of positive testimonials that are semantically related, even if the words happy customers aren't in the image tags.
Searching by meaning across text, image, video. Wow.
Exactly. Searching by meaning, not just keywords, which leads naturally to semantic search.
Okay, different from regular search.
Yeah. It finds similar items, products, documents, reviews based on their meaning, not just exact keyword matches. Search for healthy snacks, and semantic search might return fruit bars or protein shakes, even if they don't literally say healthy snacks, because it understands the concept.
Finds related things, not just exact matches. Useful for recommendations.
Hugely useful for recommendations. Or even finding duplicate records that are worded differently but mean the same thing. Improves data quality.
Okay, neat.
And finally, embeddings are fundamental for clustering, grouping similar items together, customers, articles, products for analysis or segmentation.
Finding natural groups in the data.
Right. And by visualizing these clusters, you can also spot anomalies data points way out on their own, far from any cluster. Could signal something unusual, a shift in behavior, maybe even fraud.
Outliers in the embedding space.
Exactly. And BigQuery ML supports a good range of models for creating these embeddings. Vertex AI's text and multilingual text models, a multimodal one for text-image video combined, plus its own models like PCA and autoencoder for structured data, and matrix factorization for user item embeddings in recommendations.
So tools for turning almost any data type into these meaningful numbers.
Pretty much, yeah. Gives you the right tool for the job.
Okay, so beyond the really exciting generative AI stuff, BigQuery ML also acts as this powerful bridge, right? Connecting to Google Cloud's other specialized AI APIs.
Absolutely. It's not just about LLMs. The core idea with remote models stays the same. You create that link, that pointer, within BigQuery to a specific pre-trained API.
Like the translation API or the vision
Right,
API.
exactly those. And then you use simple BigQuery ML functions to send your data to that specific API, get the insights back, all within SQL.
So you tap into these specialized AI superpowers without leaving BigQuery.
Precisely. Highly optimized AI for very specific tasks, often with incredible accuracy, made accessible through SQL.
And the benefits, we talked about simplicity, data staying put, leveraging Google's pre-trained models they apply here too, right? Maybe even more so.
Definitely worth revisiting because, yes, they become even clearer here. The simplicity is huge, no complex coding for each separate API. Your data stays secure in BigQuery, avoiding risky movement. And you leverage Google's expert models. Think
Yeah.
about it. You're not training an object detection model from scratch, which is massively complex and expensive.
Right.
You're just using Google's expert model on your data via SQL almost instantly.
Okay, let's dive into some of these specific superpowers then. What about natural language processing, NLP, with ML understand text?
Huh.
What does that let you do?
NLP is all about getting computers to really understand human language nuances. So think about those mountains of customer reviews again.
Yeah.
You can automatically categorize them: billing issue, feature request, delivery problem, positive feedback, gives you that instant actionable overview. Or run sentiment analysis to quickly gauge overall satisfaction on a product based on all the comments.
So understanding text structure and feeling. And this connects to the Cloud Natural Language API.
That's the one. Transforms raw text into structured insights.
Okay. What about translation?
Machine translation with ML Translate does exactly what it says, automatically translates text from one language to another.
Use case.
Think global customer service. You get comments or support tickets in Spanish or Japanese. Use ML Translate to instantly get them in English for your team. Makes global feedback immediately actionable. No insight lost to language barriers.
Connects to the Cloud Translation API, I assume.
You got it. Fast, accurate translations.
All right. Audio, you mentioned that earlier.
Audio transcription with ML Transcribe. Convert speech into written text. The possibilities are huge.
Like,
Automatically transcribe voicemails into text messages for quick review. No more listening to endless messages. Or, even more powerfully, turn hours and hours of customer service calls into searchable text logs.
oh, that's gold for quality assurance and training.
Absolutely. Find recurring issues across thousands of calls, train new agents. It uses the speech-to-text API, making previously locked-up audio data totally analyzable.
Okay. Document processing. That sounds potentially huge, too.
Document processing with ML Process Document. This tackles a massive business headache. Pulling structured data out of messy, unstructured documents, PDFs, scanned invoices, contracts.
The stuff that usually needs manual data entry.
Exactly. Imagine automatically pulling invoice numbers, dates, line items, vendor details from scanned invoices directly into your accounting system.
Bye-bye tedious data entry, faster payments, fewer errors.
You nailed it. This uses the Document AI API, often with specific processors trained for things like invoices or receipts. Turns messy docs into clean, usable data.
Okay, one more images. Computer vision with ML annotate image.
Right, this performs image analysis, understands visual content, it's super versatile. Detect if images contain faces, maybe for privacy blurring. Identify specific objects, count cars in a parking lot photo. Recognize furniture types in a catalog image for tagging. identify plant species in field photos.
So object recognition, classification.
Yeah, and it can also generate descriptive labels for what's in a picture outdoor scene with dog and frisbee, giving you valuable metadata. Connects to the Cloud Vision API. It's like giving your data warehouse eyes.
That's a pretty comprehensive toolkit just through SQL.
Amazing.
Yeah.
It really covers a lot of ground. But while all this Gen AI and specialized API stuff gets the headlines,
Yeah.
we shouldn't forget about traditional machine learning. Those applications are still incredibly vital for day-to-day business operations.
The bread and butter. Yeah.
Exactly. And BigQuery ML isn't just about the flashy new things. It makes these established, powerful techniques, the ones driving consistent value for years, just as accessible, just as easy to implement right there in your data warehouse.
Things like predicting sales, spotting weird patterns, building recommendation engines.
Precisely. The workhorses that keep things running and drive revenue and efficiency, BigQuery ML makes them easier too.
Okay, so let's talk forecasting. Predicting the future based on past data sales, traffic, demand. How does BigQuery ML handle that, especially for time series data?
Right, data collected over time. BigQuery ML gives you two main paths here, each with its own advantages.
Option 1.
Option 1 is for quick and easy forecasts. You use a function called AI forecast along with a built-in model called TimesFM.
Times FM. What's that?
Think of TimesFM as this universal forecasting expert that Google has already trained. It's built on a cutting-edge AI architecture, a transformer-based foundation model, basically a super smart pattern recognizer that's learned from tons and tons of diverse time series data from all over.
So it already knows about general patterns.
Exactly. You just show it your specific time series data, your last year of sales, say, and it instantly predicts the future. No training needed by you.
Wow, no training. Just point and shoot.
Pretty much. It's ideal for getting rapid forecasts, minimal setup, especially if you're just forecasting one thing, like total sales.
Okay, so key features. Cutting edge model, no training needed, very high SQL ease, just one function, uses the last 512 data points.
Right, the most recent history.
Accuracy is very high, usually, but customization is low, and it can't easily include external factors like, say, marketing campaigns.
Correct. It mainly looks at the history of the series itself. And explainability is low. It's hard to know why it predicted that number. It's a bit of a black box, albeit a very accurate one.
Okay, quick, easy, accurate, but less customizable and explainable. What's option 2?
Option 2 is for detailed and customizable forecasts. This uses a different function, ML forecast, paired with models like Aramopolis or Aramopolis XReg.
Karma, that sounds more traditional statistical.
It is, based on the well-known ARMA statistical models, but enhanced. Think of this approach as building your own specialized forecasting expert, tailored precisely to your business.
So you train it on my data.
Yes, training is required. You explicitly train it on your company's unique historical data. And you can tell it to consider things specific to your business, like holidays or promotions that impact sales.
Okay, so when would I choose this?
Choose this when you need to fine-tune the model for specific quirks in your data, maybe a really unique seasonal pattern, or crucially, when you need explainability.
Knowing the why.
Exactly. There's a function, ML Explain Forecast, that can tell you things like, sales are forecast to drop next month mainly due to the typical seasonal dip. Not just the number, but the reason.
That's valuable.
Very. It's also the choice when your forecast needs to incorporate those external factors, covariates, like ad spend, competitor actions, economic indicators. If you have historical data for those, the ARMA plus XRED model can use them.
So XRE means external regressors, those factors.
Precisely. And it can handle forecasting multiple related time series at once, too.
Okay, key features here. Statistical ARMA models, training is required using create model. SQL ease is still high, but needs a create step, uses all training data usually.
Provides more historical context.
Accuracy also very high. Customization is high. You can tweak seasonality, holidays, trends, clean up spikes.
Lots of knobs to turn.
Yes, to covariates with SXRA. And explainability is high, using ML.explain forecast.
You got it. So 2 great options depending on whether you need speed and simplicity or control and explainability.
Makes sense. Okay, beyond predicting the future, what about being a data detective? Finding the weird stuff. Anomaly detection.
Yeah, finding anything weird, unusual, out of place compared to the normal baseline in your data.
Why is that useful again?
Oh, tons of reasons. Spotting problems like a sudden server error rate spike, catching fraud, that unusual credit card charge way outside someone's normal pattern, even finding opportunities, maybe a product suddenly selling way more than usual, indicating a new trend or a hit campaign.
Right, like that example of product return rates suddenly jumping. Could be a defect, could be fraud. Anomaly detection flags it.
Exactly. Now, how BigQuery ML helps you find these depends on what you already know about your data. First, what if you have labeled data? Meaning you have historical examples already marked normal or anomaly, like confirmed past fraud cases.
You know what bad looks like.
Right. Then you use supervised learning. You train a model on this labeled data. It learns the patterns of normal versus anomalous. Then you use ML predictee on new data, and the model flags things that look like the anomalies it learned about.
What kind of models?
BigQuery ML supports a bunch for this. Logistic regression, boosted trees, random forest, DNNs, wide and deep, even AutoML classifiers, which find the best model for you automatically. Plenty of choices.
Okay, that's if you have labeled examples. What if you don't have labeled data? You're just looking for anything statistically weird.
Very common scenario. That's where unsupervised learning comes in, using the specific ML detect anomalies function.
How does that work?
Well, for time series data points over time, you can use those IRMA models again. IRMA Plus finds anomalies in a single time series compared to its own history. IRMA Plus XXReg finds anomalies even after accounting for external factors you provide.
Finds unexpected spikes or dips in time.
Exactly. Now, for data that's not a time series, just independent data points like customer records or individual transactions called IID data,
Yeah.
BigQuery ML offers a few unsupervised methods. K-means clustering is one. It groups similar data points into clusters. Anomalies are points that are really far away from any cluster center.
The odd one out that doesn't fit in any group.
Precisely, like a customer whose buying habits are totally different from any established customer segment.
Okay, what else?
There's the autoencoder. This is clever. It's a type of neural network that tries to compress your data and then reconstruct it back to the original.
Compress and decompress. Why?
If the model struggles to reconstruct a particular data point accurately, if the reconstruction has a high loss or error, that point is likely an anomaly. It didn't fit the normal patterns the model learned during compression.
Like trying to draw a weird face from memory.
Uh,
It comes out wrong because it's unfamiliar.
That's a great analogy. It struggles to reconstruct things that deviate from the norm it learned.
And PCA.
PCA, principal component analysis, works similarly, also using reconstruction loss. It simplifies the data down to its main underlying patterns, principal components, and sees how well the original data can be rebuilt from that simplified version. High error means anomaly.
So several ways to find the statistical oddities even without prior examples.
Yep, powerful tools for uncovering the unexpected. Okay, let's switch to recommendation systems. These are like those super smart personal shoppers you see online, right? Helping people find stuff, products, videos, articles they'll find interesting, even if they weren't searching for it.
Like YouTube knowing what I want to watch next.
Yeah,
Sometimes spookily well.
exactly. And why are they so important for businesses? Well, first, they go beyond search. Users often don't know what to search for. Recommendations expose them to more relevant stuff.
Increases discovery.
Right, which leads to increased engagement. People spend more time if they're finding things they like. And that, especially for e-commerce, means higher sales and conversions. More relevant suggestions mean people buy more.
Makes sense. Drives business value.
Hmm.
So how do they work fundamentally?
Generally, two main approaches. First is content-based filtering. This recommends items similar to things the user has already liked or interacted with. It focuses on item characteristics.
Based on item features.
Yeah. You watch cat videos, it sees the cat, cute, video tags, and recommends other videos with similar tags, puppy videos, funny animal clips, based on what content you liked.
Okay, what's the other way?
Collaborative filtering. This is different. It finds users who are similar to you in their tastes and then suggests items that those similar users liked. It's about patterns in user behavior.
Based on what similar people like.
Exactly. If you and your friend like similar movies and your friend just loved a new superhero film, the system recommends it to you, leveraging the wisdom of the crowd or similar users.
Two different logics. How does BigQuery ML help build these?
It has models for both. For collaborative filtering, a very common technique is matrix factorization. You use the ML recommend function for this.
Matrix factorization?
Yeah.
Sounds complex.
The concept is cool. Imagine that big user item interaction grid. Matrix factorization breaks it down mathematically to find hidden underlying factors or preferences for both users and items.
Hidden factors, like genre preferences.
Could be. Like figuring out a user has high scores for sci-fi and comedy factors, and a movie has high scores for those same factors. It then multiplies these factors to predict how much the user might like that unseen movie.
Predicts ratings based on shared hidden tastes. Clever.
It is, but sometimes you need more complex recommendations. BigQuery ML also supports using deep neural network (DNN) models for recommendations.
DNNs again?
Yeah, they can find really intricate patterns. They're great when you have lots of different features about users, demographics, history, and items, descriptions, categories to consider, leading to highly personalized suggestions. You use ML Predict with these.
For richer, more nuanced recommendations.
Exactly. And they're also wide and deep models. These are hybrids. They combine a simpler wide part that's good at memorizing common rules, like popular items often get recommended, with a deep neural network part that's good at generalizing to find new, less obvious connections.
Best of both worlds. Memorization and discovery.
Kind of, yeah. Aims for both relevance and diversity in recommendations. Also uses ML Predict, so you've got options from straightforward collaborative filtering to really sophisticated deep learning models, all to help users find what they'll love.
That's a great toolkit for keeping users engaged. Okay, final big area, classification. Sorting data into categories sounds fundamental.
It absolutely is a cornerstone of machine learning. You're basically teaching a computer model to sort new, unseen data into predefined categories or labels based on patterns learned from historical data you've already labeled.
Like training a smart sorting assistant.
Perfect analogy. And common examples are everywhere. Is an email spam or not spam? That's binary classification, 2 outcomes. Sentiment analysis, positive, negative, or neutral review. That's multi-class classification, more than 2 outcomes. Other huge ones. Customer churn prediction, well, churn won't churn. Fraud detection, fraudulent legitimate transaction.
Automating those sorting decisions at scale, how does BigQML help?
Simple workflow again. Train a classification model on your labeled data using create model, then use ML Predict on new data to get the predicted category.
Okay, what models does it offer for this?
A good range, letting you pick the right tool. You choose using the model type option during creation.
First,
Logistic regression. Logistic reg. Great for simpler tasks, especially binary yes-no outcomes, but handles multi-class too. Think of it as finding the best boundary line to separate your categories. Efficient and interpretable.
good starting point. Next,
Boosted tree models. Boosted tree classifier. Very accurate, very powerful for many problems, especially with tabular data and complex relationships. It builds many decision trees sequentially, each learning from the previous one's mistakes. Like an expert team improving over time.
high performance. What about random forest?
Random forest models. Random forest classifier. Also highly accurate and robust. Builds many independent decision trees and takes a majority vote for the final classification, like many independent experts voting. Reduces errors, good generalization.
Another strong tree-based option, DNNs.
Deep neural network models. DNN classifier. For complex problems, lots of data, intricate patterns. Inspired by the brain, multi-layered thinking machines, learning abstract features. Excel when simpler models might struggle.
For the really tough problems.
And wide and deep.
Wide and deep models, DNN linear combined classifier, that hybrid again, combines memorizing simple rules, wide part, with generalizing complex patterns, deep part. Effective when you have both straightforward signals and subtle nuances in your data.
Flexible and powerful. Last one, AutoML.
AutoML models, AutoML classifier. The easy button for excellent results without deep tuning expertise. You tell it the goal, and this expert system tries lots of models and settings automatically to find the best one for your specific data. Often gives top-tier results with minimal effort. So a whole spectrum, from simple logistic regression to automated AutoML, all for classification within SQL.
Exactly. Makes this fundamental task very accessible and powerful within BigQuery.
Wow, okay. We have covered a ton of ground. It really feels like BigQuery ML is transforming what you can do with data, doesn't it?
It really does.
I mean, from generating text and understanding images with Gen AI to those specialized tasks like document processing or translation, and then diving deep into the traditional powerhouses like forecasting, anomaly detection, recommendations, classification. It's all there.
Mm-hmm.
And the core message that keeps coming through is You can harness all this sophisticated AI right inside your data warehouse, mostly using SQL, keeping your data secure, avoiding those old migration nightmares.
That's the key takeaway. Accessibility, power, and security, all integrated.
If we just zoom out for a second, connect this to the bigger picture, what feels really fascinating is how this accessibility could genuinely democratize advanced AI.
Yeah, that's a huge implication.
It's moving the application of AI, maybe not the core research, but the use of it, from being solely the domain of specialized data scientists and ML engineers, who are still vital, obviously
Yeah,
vital,
absolutely.
but making it accessible to pretty much anyone who's comfortable with SQL. That's a massive shift.
It really lowers the barrier significantly.
So this raises a really interesting question, maybe a provocative thought for everyone listening. If that barrier to entry for using serious AI is lowered so dramatically, what entirely new applications, what powerful insights might you uncover in your own data?
Right. What problems that seemed too hard before are now within reach.
Exactly. What previously insurmountable challenges could you solve? What amazing new opportunities might you discover? Things that were just too complex, too resource-intensive, maybe just too intimidating to even think about tackling before.
It really opens up the possibilities for creativity and innovation, letting people who know their data best apply AI directly.
Yeah, it feels like a moment where human ingenuity, combined with this newly accessible AI,
Mm.
can really start to flourish in new ways.
Well said.
We really hope this deep dive has given you some serious aha moments, maybe spark some concrete ideas for how you might unlock those AI superpowers hidden inside your own data sets. What kind of project are you thinking about tackling with BigQuery ML after hearing all this?
It's definitely worth exploring.
Absolutely. We encourage you to explore, experiment, and just see what knowledge, what insights you can uncover. The tools are becoming incredibly powerful and accessible.